Hi everyone, it is good to meet you all in the next video of Python tutorial series. In this video, we will discuss about k nearest neighbors algorithm. So KNN algorithm is also a supervised classification model. Here we will determine the class of an unknown data point based on the nearest neighbors characteristics. For example, here we have one green data point which is to be classified as square or triangle. If the value of k is 3, the algorithm will take 3 nearest neighbors and try to classify it based on the characteristics of the neighbors. If the k equal to 5, we will consider 5 nearest neighbors and take the majority of the characteristics of the neighbors. So for example, here if k equal to 3, we have taken these 3 nearest neighbors to the data point, and if you see, the majority of the shapes is triangle. So we will be classifying this unknown data point as triangle if the given value of k is 3. If we give k equal to 5, we will take these two shapes as well into consideration. So the majority of shapes is square now. So this unknown data point will become square. So what is this k value? So k value determines the number of nearest neighbors to refer. So how do we choose this k value? K value is any positive integer. For example, it starts with 1 and it can be up to n, where n is any positive integer, and it can be chosen by parameter tuning. Parameter tuning is nothing but we start from 1 as k value, and we keep on increase the k value until we find the more accurate model. It is advised to choose k value as odd number, because in some cases we will end up in a tie situation if we choose k value as even. For example, if I choose k value as 4 and two neighbors are holding one characteristics and another two neighbors are holding another characteristics, it will be difficult to choose which characteristics to go for an unknown data point. So it is advisable to choose k as odd number. So how we calculate the distance in KNN algorithm is, we will be calculating the distance by using Euclidean distance metric. Here the distance is calculated based on the below formula. Let's say there are two data points xy and ab. The distance can be calculated by taking the square root of x minus a the whole square plus y minus b the whole square. For example, there are 2 points P1 and P2. P1 lies at 1, 1 and P2 lies at 5, 4. Here the distance can be calculated by square root of 5 minus 1 the whole square plus 4 minus 1 the whole square, which is the Euclidean distance between P1 and P2 points. So in our case, the nearest neighbor means whichever the data points which are having lesser Euclidean distance is considered as the nearest data point. So let us solve one KNN algorithm using one example. Here we have result of normal or underweight based on the person's height and weight. This is one sample data. While plotting, we have got this, and let us say there is one more new person for whom we have to determine the result. Let's say that person is having 160 as height and 54 as weight, so he falls here. So barely by looking at the image, if we say k equal to 3, he falls into normal category. So let us solve this by calculating the Euclidean distance from this new data point to all these known data points. So for the data point 1, we got 10 as a Euclidean distance. For data point 2, we got 6 as a Euclidean distance. For third data point, we got 5.099. Similarly, we got 20 for data point 4 and 14.866 for data point 5. If we take 3 as a k value, we will get these first 3 data points as nearest neighbors, because out of the 5 data points, these 3 are closer to our unknown data point, which is 160, 54. So here there is no competition and all of the neighbors are holding the characteristic as normal. So our unknown data point will also be classified as normal. If I place a circle for k equal to 3, these 3 data points are nearest to our new data point, and hence our new data point will also be classified as normal. So that's all with respect to KNN algorithm. In the next video, we'll be implementing this KNN algorithm in Python language. So until then, see you. Have a great day.